Streaming. Right, so in today's lecture, my plan is to talk about reflection, particularly when we look at the assignment or the whole course, the project that you're being asked to complete. If we have a look at the submission, you can see that we've got the individual reflections on code that you consider good, code that you consider bad, and personal reflections about the key concept you learnt during the course. And we want you to allocate who did what in particular files when it's relevant and important. So, reflecting on what's good and bad. What do I mean by good and bad code, and what do I mean by reflecting on good and bad code, and what do I mean by reflecting on development? Right? So I thought maybe if we could cover some of that, we can perhaps set some of your minds at ease. And what we'll do is we'll go through this, and then you can ask me questions, and we can go back and forth around what you're expected to do. I also need some time so I can talk to some individual students at the end about their projects and give them feedback on their games and how they're progressing, so that we'll be able to have good outcomes. Okay, so the point of reflecting on what you've done is that, unfortunately, one of the problems we have at university is we tend to drive you quite hard from assignment to assignment to assignment to assignment without necessarily giving you much space to just think about what you've done. Right? Now, this is partly because what we find is if we give young people in their 20s a bunch of free time, they tend not to just think about what they've previously done. They think about going and, having fun, going for a drink, relaxing, trying to cope with life. So what you've seen is a lot of universities move into this constant action phase, right? Where there's no time to reflect or improve or update your knowledge because you're just being asked to move, boom, 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 all the way through things. So what I want to do is I want to give you that opportunity to reflect on your learning and reflect both as you go and at the end. Now, to get the most out of an experience, it's better if you prepare yourself for the learning experience, right? So if you're going to learn from experience, you've got to prepare to learn. And the best way to do that is understanding what you do not know and setting up your environment to get that information, right? So part of what we want you to do is to, at the moment, note down some things, right? Start setting up your environment to help you learn. Start documenting things where you're going to try and do something and you don't know how to do it, because then that's an example of you learning something new. It allows you to reflect on how far you've come. Because one of the problems that we have is that our brains will often retcon reality and go, oh yeah, no, I've always thought that. Right? And so we have this idea of we always thought it was only going to take us 2 hours to do something, and so we end up taking 4 hours, but we think, oh yeah, no, it was going to be 4. Of course I thought that. So, collecting notes, collecting insights, analysing your experience with the active intent of changing your behaviour. Right? So, when you know that what you're trying to do is to try and change the brain, right? Because the problem is if you think that what you're trying to do is to produce an artifact, right? Make a game, for example. You'll get very hung up on, oh, I'm trying to make this artifact. I'm trying to make the game, right? But for a university, we don't care about the artifact really. We often will be marking artifacts because that's the only thing we know how to mark. We care about what's happening inside your brain, what's changing in your brain. And so we want you to set up and approach the activity of development as a learning activity rather than a production activity. And that means that you're preparing to learn. So before you start, sometimes you'll do a pre-test. I can absolutely get, me and AI, to go through and write a pre-test around what do you know, right? And those pre-tests can be your own, or they can be just a general feeling of, what do you know about game development? And then, do you understand all the words that are going to be used? If we have a look at a vocabulary of game development, as we go through and say, if I talk about a main loop or what is the dominant strategy? Do you have a dominant strategy in your game? So, go and start reading some things to find if you understand the lexicon, right? The words used. If you are looking at trying to learn something, you can also look at the resources you currently have, and you say, are they current? Are they up to date? Are they verified? Do you know that they're true? Who should you trust in a space, and what resources do you have to learn? Now, the answer to your questions in this course is that you are using me as part of a trusted resource, and you've decided to use the university as a trusted resource. However, if you go out into the real world next year, you will be having to find your own verified resources. You'll have to find what is current and what is outdated. You will have to develop an idea of how do you trust information coming from a particular source. So that's where you get to the sort of, okay, I'm going to need to think about how I create my environment that helps me learn. And this comes into this intentional experience. Now, you would have heard the 10,000 hours. I'm assuming it's repeated in Norway as well. To be an expert in something, you have to do it for 10,000 hours. Well, actually, that 10,000 hours is 10,000 hours of intentional activity. Right? What that means is you can't just be passively doing the things. You have to read with intent, and you have to act with intent. And you have to do hypothesis testing. Now, what I mean by read with intent, one of our postgraduate research coordinators, he said his job at Oxford was to teach PhD students how to read. It kind of seems an odd thing that you'd need to teach a PhD student how to read because they've done a bachelor and master's. But he said that most people and most undergraduate and most master students read to broaden their understanding, right? They're reading to acquire knowledge. They're not reading with intent, where their intent is to evaluate the knowledge being presented. All right, so as you go up the knowledge hierarchy, you go from reading because you want to find out what it says, to reading to say, well, I want to know if what it says is true. And so that's where you start reading with the intent to find citations. You read with the intent to challenge the material you're being given, with the intent to extract all of the information out of it, rather than necessarily just the surface level facts they're trying to tell you. You might dig in and go, well, what do they actually mean by that? And we're of course seeing this in Donald Trump and Tylenol, so paracetamol that we use. Acetaminophen? Anyway, we are, in some of that, if you were just reading it to absorb what he's saying, that's kind of level one knowledge acquisition. That is very different to the intent where you say, right, I want to find the justifications for what he's saying, or I want to extract the forms of argument and rhetoric that is being used. I want to understand the fallacies that are in this document. Okay, so all of that reflect and learning to intend, we are not just looking for you to have acquired information. We're starting you to go into this area of thinking beyond the surface level. Right? So when I want you to reflect, it's not just telling me what happened, right? It's also thinking about why it happened, or how do I transfer knowledge from this into other scenarios? What is the abstract concept that this particular instance shows us, right? So if the instance is you had an argument with one of the other students about an asset in the game, okay, you might say, oh, I had an argument. But then you could reflect on that and go, okay, what did I contribute to that argument? Did I escalate? Was I listening? Did I create a hostile environment? What was my role? And then say, what did that person bring to that argument that wasn't clear in their communication? Is there another part of the game that's going wrong? They have another course where they're stressing about it? Is there a deeper level fear of imposter syndrome or something where they are not confident and so they're having to bring up more things to try and justify that they're good enough at this, right? So acting with intent, reading with intent, thinking beyond the surface layer. And that's what we're looking for in the reflections that I want at the end of the year. I want you to be thinking about what the project meant in terms of what you can extract from it. It also means that you need to think about some, and this is where you come in early, when there are problems, when you're trying to work out how something works, you come up with hypothesis testing. Right? And hypothesis testing is that you've got to be able to measure what's currently going on, then come up with a hypothesis, right, about the relationships between entities, and then change something and collect new data, right? Because this is the intervention things, right? So you look at the way the world is, you make a hypothesis that if I change this, this will happen. Change that thing and see what happens, right? And when you change it, you should be able to say, because you're measuring things, when you will know that the consequent measure is a result of you doing the thing, right? Of your intervention. And so this is this debugging is hypothesis testing. The idea of thinking about how your rule change in your game will affect your players. Right? Now, if you've never had any play testing, you don't know if it's going to affect the players because you don't have a pre and post, the intervention. So that's why kind of often before you do something, you have to start testing and gathering information. And this falls into the thinking about what experiments you're doing, taking some baseline early data, getting understanding the situation you currently have, and then doing something to change it and seeing what happens. In game companies, we generally have, and actually all software development, we start talking about, you'll have to deal with the difference between exploiting what you currently know and exploring new things to learn. Now what we mean is that for most projects, you'll be able to look at something and go, oh, okay, I'm going to code that up. If you code it up using all the tools you currently know, let's say it was going to take you 10 hours. But you think that Python or Rust might have a library that will do much of what you're wanting to do, but you don't know how to use the library. So, how much time do you spend learning a new tool that might turn that 10-hour process into a 3-hour process? So it would save you 7 hours. Okay? But you have a level of uncertainty on that. In education, we want you to lean heavily into learn the new tool, learn the new thing. Don't do busy work of make it just exploiting what you currently know to produce an artifact. You should be using it as an opportunity to learn new ways to produce artifacts. And so that's where most of uni is exploration, or supposed to be exploration, because we're supposed to give you tasks that are harder than you currently know how to do. So you're forced to explore to find new solutions. However, a lot of work sells the artifact, and so they want you to focus on exploiting what you currently know to get the artifact out the door. Knowing the difference between those two, knowing the difference between the scoping of time that is exploring versus time that's exploiting is something you need to give your boss. Now, your boss may absolutely bill the client for either all the time or only the exploitation time, because they treat your exploring, they treat your learning as value to the company. And so they're saying, well, we can give a discount to this user because we learned a lot that we're going to then continue and use in the next project. So we'll only charge them for the time which we would normally have used building this rather than the whole time. And we just know that in the next project we'll be able to do it in half the time, so we can bid for lower. Right? So there's this idea of you can loss lead, you can give away a product for cheaper than it's cost you to develop it, if on the back end you are gaining knowledge in your head, or new skills, or new code, or a new resource. Okay. With exploring and exploiting, there's also this concept of technical debt. Now, have you guys had people talking to you about technical debt? Is this something you've been tasked with understanding? I've jumped back to the Discord window. Okay, so Sarah hasn't heard of technical debt. Have other people heard of technical debt? We're getting a couple more hands up. Frederick's heard of it. A bit not sure it's in classes. Okay, so the idea of technical debt, the reason why we call it debt is because you are borrowing from the future. Okay, so and therefore it's debt, and there is interest to be paid. So technical debt is where you throw together a solution in that exploiting phase where you just try to get it done, right? So you start a project with good commit messages, so the stuff you're doing at the moment, hopefully you're creating issues in your repo, and when you commit to the repo, you are adding an issue number for at least some of the commits you're making. You spend a bit of time to write them so that they're good commits. The code you write, you've got a bit extra time, so you make it actually okay. But then as you get closer and closer to the end of the project, you start pushing harder and harder, and you don't take so much time to clean things up, and you do the thing, you just go, I'll just do it, right? I won't think about what's the best way of doing it, or if there's a more efficient, I won't learn a new way of doing things. I just have to get this out the door and then I can move on. So technical debt is where you have built up some problems in your code, things that need to be refactored, things you know that are hacky, things you know that there's better solution to. You've cut and pasted code when you know you should be writing a function that unifies all of these blocks of code, but it's just faster to cut and paste, change a variable, and move on than actually create a proper function. So it's all of the pushing of both known and unknown problems, right? So, you know, maybe there's a refactoring and you don't know how long it's going to take, or there's some sort of bug that happens. And so what you do is you just disable that part of the play mechanic, right? You go, you know, my backpack's buggy. I therefore just won't have a backpack. I'll just let you have 10 items, and it'll only be 10 items. We won't have a backpack because I've got a backpack, but it's buggy, so I'll just disable it. That buggy backpack that you've disabled is technical debt if you want to get back to a fully functional system. And anytime as you just make some poor decisions, or even just it grows organically so that it needs to be refactored, once you know it needs to be refactored, that is an example of technical debt. And what happens with technical debt is that if you don't pay it back, if you don't go back and you do the work to refactor, every time you add a new item to your finite state machine because you haven't refactored it to be object oriented, you have to do a bunch of extra work to integrate the change. The nasty cycle is when no individual change, no addition you need to make, is greater than the debt, right? So you say, well, refactoring will take 2 days. It only takes me half a day to add a new item. So, yeah, like the in the moment cost is less than the full refactor cost. And so you leave the debt in there and you just pay the interest every time you have to make a new item. The problem is you might end up, if you're not looking ahead and seeing how many items you had to produce, or how likely they are to change, or how likely they are to make other changes, you don't look at the debt properly and you leave it in there. Right? And so, you know, should I use my, that should be no in, there should be an in there. Should I use my no in slow process, or learn the correct way of doing X? Right? So this is that leaving in technical debt, particularly refactoring debt or documentation debt, or you know, edge case debt. So there's a whole bunch of this idea that there are things that need to be done which you might not have done. Now, those things can come to light on what's called a during action review, which has a cousin in an after action review. This is a military term used by the Norwegian military. We did some consultation work with the Norwegian military, and they do during action reviews and after action reviews. So the during action reviews are while you are performing some sort of task, you're in some sort of long-term, medium-term engagement, and at the end of the day, you might pause and do a during action review, right? And say, okay, what situation? You know, where are the tanks? What do we know about the terrain? Where is our air support? So you're doing a quick review of what the situation is. Now, those in Scrum are a wee bit like your daily stand-ups, where it's forced to have a short meeting, which is why we call them stand-ups, because people don't like standing for too long. Well, programmers don't like standing for too long, and so by making them stand up, you mean that they're not going to sit around in the meeting for too long. Right? So if you want to have shorter meetings, make them uncomfortable physically for the people in the meeting. But the idea of those stand-ups is that you do a very quick plus what's going well, minus what's going badly, and delta what should we change. And if you find that something's going badly or that you need to change, then you ask, what is missing? Is it you're missing a piece of knowledge? You don't know how to do the thing you're trying to achieve. Right? There's a piece of knowledge missing from your understanding of the code or the environment or processes. Is there a resource you're missing? That can either be resource to that you need more time, so you're negotiating deadline, or you need additional people on the team, or you need some skills that you don't have, or you need to buy an art library, or there can be lots of those different challenges. And that's another thing you can identify during the review is what's missing. And then there's the dilemma, right? So the dilemma is that you've got two paths. You have two paths that you could take. You've got resources, usually only for one of them. You know generally what's going on, but you don't know which is the best path to pick. And this might be not just a simple A is faster than B, but could be, citrus versus apple, right? So an orange versus an apple, there isn't a true right answer. it's a dilemma you've got to pick based on what your audience might like and all those sort of things, right? So there's a review of what you're missing, knowledge, resources, or a way to differentiate potential paths. Now, that during action review, you should be probably for you all once a week at least doing the very quickly, each of you say what has gone well for you in the project this week and what has gone badly this week and what needs to change. Now, and it's best, don't have to, but it's best if you can find a way to document that, because at the end of the semester, when I ask you to write that reflection on what went well and what went badly and what you extracted from that, having a list of your weekly this thing was going badly and this thing was going well means that when you go to look back at that, you have those notes. Right? Otherwise, you're going to have to try and work much harder to think about it and work it out later. Games have a very specific way of doing the after action review. So the during action review, stand-ups. After action review is what we call post-mortems. The post-mortem is the idea that you discuss goods, bads, and sometimes they'll add things to change, right? So often, sometimes it's a 5-5-3. So 5 good, 5 bad, and 3 things to change. And they make it 5 good and 5 bad. So you explicitly have to say what went well and look and hunt for things that went well if things went badly. You also want to say the 5 things that went badly, because that's where you get the most learning from, right? Is going and looking at these. And so if we have a look, here's a whole bunch of postmortems from Game Developer Magazine, right? So Game Developer Magazine took over from Kotaku, which used to hold all these, but Game Developer Magazine holds these now. And you can see some historic ones that were posted recently, so classic postmortems, as well as modern postmortems. And the idea here is that if you go into one of the postmortems, and I haven't actually looked at this particular one, and you'll find that it's an 8-minute read, and it goes through and talks about, describes the project, so that's the standard thing we do, is describe what it was, and then you go into your what went right, okay? And this is a really interesting way to read about what professional game developers' problems and successes are. This allows you, when you're in your own development, to try and think about, what is going well, what is going badly, how am I going to maximize that we are succeeding, right? And part of that, document early, rapid prototyping and rapid iteration. Don't think that you can push your integration till way late in the project, because if you all go and work separately and then just think, oh yeah, we can all pull it together in the last week, it'll fall apart and be horrific. You have to integrate, prototype, test and iterate really early, right? So that's what this is saying. Streamline DevOps and playtesting. Again, getting the the implementation to get to a game where you can take it to a player. DevOps is the development operation, so that you can get the code to a playable state early so you can get the testers to play it. Optimizing and mobile compatibility. You're not generally going to have long enough to optimize your code. Getting it working is going to be a win. And what went wrong? Limited customization and code access. So they didn't they didn't have enough features. Asset import challenges. So
we can only see the first page of your presentation.
Oh, you can only see the page of my presentation. I thought it was. Okay. I'm showing something. Sorry, I am showing something, and it went back to the first page because I clicked off it. So that is there. Why am I... Okay, so that's there. And I need to go to here and see, okay. Okay, have you only ever seen the first page of it, or was it following along? Yeah. Okay. That's... Okay, let's change stops. Change screen. That's very... Let's go to the entire screen. And just go that entire screen. And I'll share the entire screen. Only for 3 to 4 minutes. Okay, phew. I was just thinking you guys had sat there on the front screen for the whole time and I'd just been ignoring you. That would have been terrible. Right, when I'm clicking. So if I go back to here and we go back to this, and because these are all good postmortems. If we go and have a look at the Game Developer Magazine postmortem, now hopefully, thank you for interjecting and saying that you weren't able to follow it. Speak up if you're not following it now. This one I had gone to here, and I'd actually gone down to the postmortem, bringing the Circle Frontier to Unreal Editor for Fortnite. Right, so I'd just gone into that one because it was a late last year one, and so I'd been going through this, which is what I was talking about, and saying, well, it actually has down here what went right: rapid prototyping and iteration, streamlined dev, optimize the mobile compatibility, and then we're into the what went wrong. So this is why I've asked you in your reflection on your project to write about what's gone well and what's gone badly. It is much easier to remember what goes badly if you're documenting it at the time, right? So limited access to customization codes, that's the thing. Asset import challenges. Importing assets in the original Unreal project, Unreal Fortnite, from the original Unreal to Fortnite proved to be more difficult than anticipated. And this is a classic thing, because you're used to asset importing in games often as you click the import, you find the asset, you go bang, and it's there. While the basic elements like meshes and textures imported without much trouble, we ran into significant issues with materials. The Cycle Frontier project used a lot of custom material functions that were incompatible with Unreal Engine Fortnite, often resulting in crashes. So this is something that you wouldn't know when you started a project, that is going to take a while. So when you make a plan, you make a plan with the best evidence you have, and in this case, the best evidence they had, we'll spend 3 or 4 days doing the asset import because we've got it fully working in Unreal. And Fortnite did I hate those materials. I can't cope with those because I have different functions underneath. And suddenly something goes from a 1-week task into a 5-week task because you've got to rewrite all your materials, right? So it's that kind of miss that can be a problem, right? So as it says, limitation forces us to rebuild much of the environment and much of the assets. While this ensured better competitive performance, it also meant that our version of looked and felt more like Fortnite than we initially intended. So they were wanting to use the Fortnite engine, but then they had to recode it, and it looked more like Fortnite because that's what the Unreal Fortnite engine could maintain. debugging limitations, so like getting debug information can be a problem. So yeah, and then they give a conclusion. Okay, so there's this idea that this is a way that game developers use to talk about game development. So I've given you a list here of 10 classic ones that I've read and like. These are older games, so like you don't have to read these ones, but the idea is that they give you an insight into the game development process from experts, from professionals, and I want you to think about that when you are writing your final report, that I want you to have more like some of these postmortems. Now, as you can see, this is now 25 years old, 24 years old, right? So this stuff is old, but this is, Peter Molyneux, well-respected game designer. This was his reflection on Black and White. It got finished, right? The first thing that he says, sounds stupid, but we encounter some big problems. So getting finished is a good thing to do. All the risk paid off. That might not work for you. The game looks stunning. He really likes the look of that game. The AI, the creature AI, as I mentioned, was absolutely spot on. So 25 years ago, we were talking about AI being really important in games. And, the way that the team came together, right? So that team collaboration. And then what went wrong? Planning a story, fixing bugs. Now, you see this one from 2024, bug fixing, right? So bug fixing often ends up something in the negative. So after cancelling our Christmas party on December 26th, 2000, we managed to hit alpha, which as any developer knows, is a very loose definition, but at least we could say that the game was featured. It was now feature locked. After a well-deserved Christmas break, we came back to find that we had more than 3,000 bugs. We had 6 weeks to reduce this to 0. But the thing about bug fixing is that you solve one bug, and in doing so create 3 more. So although we worked as hard as we could, the overall figure crept down slowly rather than dropping at a rate that would be actually sorting out the bugs. So just as you experience, big games, big famous game developers have the same problem. You fix bugs and there are more bugs, right? So the team's very tired. They keep going through the scene. So we had bug lists circulating with every member of staff. So yeah, bugs were a challenge. The project was too big. You might find that for some of your projects, that you try and make things too big. Having to leave things out that they really liked was a problem. And release dates. They also missed some of their release dates. So this is, and then the conclusion about the project, and so yes, people told Lionhead we were perfectionists, but if we were, the game would never have been finished. It's not a perfect game. Our next game won't be either, but that's because not such a perfect game. So that's, you can see this is them reflecting on a criticism from other people that thought of trying to be perfectionist, right? So for your projects as game developers, I want you to take those professional approaches to writing good reflections. Okay, so I'll leave that list there, and I'll download this as the new PDF. And that was the end of that first hour, because I wanted to give you time to ask questions and also do some of your work in teams. So we're just on 10 o'clock my time, 11 your time. Do you have any questions about the reflections and what we expect you to do, or okay, so we can also talk more about what good code and bad code is. So I've talked about the reflection component. I can come back and we can talk more about good code and bad code. I want you to be making. I want your game to be. I want you to be starting working on a game. You need to have decided the engine you're working in. You need to be coding up parts of your game. Potentially deciding whether you're going to have networking or not. If you are going to do networking, then I was thinking of doing networking this week, but I'm not at home, so I can't do that easily. But I think we did some networking with you guys. But yeah, so what is the next thing you most want from me? I see there's a question coming in. I can also give you the lecture on extremism that I gave over to discuss extremism. We have an ethics lecture coming up, which I'd like to give you guys. There are a bunch of lectures on optimization in game engines that we can do, some more on graphics and shaders and graphic pipelines. So I'll need a steer as to what next Monday looks like, and also me jumping into your individual groups in the second hour of this lecture to talk through with each of you how things are going, right? And make sure that I'm giving feedback to all the groups and they can show me what you're up to, and I can give you steer on how you're going in the game and what you're looking like. Do I have any good resources on how to write good GDScript code? It's a little different when there are nodes and scenes get involved. I think the best resource is actually the Godot tutorials. They tend to have the best Godot 4.4 examples. If you want really good Godot code, what I would do is we could do a code review, and I think the okay. So some basic things to know. One is, as you said, the scenes and nodes. Think of scenes as having a kind of nodes with cameras. So scenes are things where there is a camera, it's looking at a root node, and that root node has all the nodes underneath it. And you can add scenes to other scenes, which then basically mean that you take that scene's camera away, but you put it in the other scene. And think of everything as nodes and hierarchies, and think of them as hierarchical. The other important thing to do is to not get too stuck in, with Godot, thinking that if you want to trigger an event in another part of the game, that you have to have an explicit pointer to the thing you're going to change. So in Godot you can go and find the name of another of the root node. You can go up from you can go up layers to get to the root node, and then down children to get to another item in the world. But if you do that, you build these like definite connections, and if something moves or the hierarchy changes, then your code breaks. Very fragile way to code. So Godot 1 is you think of everything as nodes, and you think of using events, right? And so you use the events and signals to emit signals and listen and respond to those signals. Okay? So when you're thinking of an object crashing into another object, and you want to emit damage, I want to damage you. It's a kind of, okay, maybe we need to emit that damage has occurred, and then everybody listening to that damage receives the damage, right? So we use that event listening pattern. Use if you know it's just a thing that you're colliding with, use the object in the event information to say, the event to the object that hit me is for it to take damage. right? Whereas if you are doing splash damage, or you're emitting a sound or doing something which multiple things might need to listen to, then try and think about your game as separate entities in a world. Think about how those entities interact. Right? So, yeah. So I would say that unfortunately, it is the Godot tutorials are the best resource for this, and doing code reviews in class, where people show off the code either in the group rooms that we can break up into, which are all these group rooms here, or we do it in front of everyone, because sometimes code reviewing in front of the team means that more people get to see your code, so you get more eyes to find any bugs or have good ideas and fix things. Okay, Alex, you're writing. I think we can have a 15-minute break, and I'll come back. We'll have the break, and when we come back, everybody will be in their groups. Right, a codec. So yes, as you can see, the first thing he says is custom signals, and that's what I was talking about. Those event signaling is the custom signals. Dynamic resources are rather than putting everything into the level scene, right? You want to spawn objects, right? So you set things up so you don't have to place them all the time. That you can actually create that, and you get those dynamic resources being allocated. Classes and state management, inheritance. Hopefully you've heard of inheritance. Better singleton decoupling systems, or better singletons and decoupling systems. I think we talked about singletons in the design patterns. Enums are ways of dealing with integers, setters and getters. Hopefully you've heard of setters and getters. Right. So it works, but you have no way of knowing if the solution is good or not. Okay, so the best way to find out if the solution is good or not is actually to show it to other programmers and get them to explain what's going on. Because part of a good solution will be the fact that other people understand what you're doing. Because you have two types of testing. One is testing functionality, and one is testing maintainability, reusability, understandability, readability, right? So all of those human aspects. So unfortunately, you only get to know those when you show your code to other programmers. And that's partly what a code review is for. So us as seniors, part of our job is to help you understand what is good code. There are some static code analysis tools that you can also run. Have you heard of static code analysis? So there's a bunch of static code analysis tools. I don't know if there's a static code analysis tool for Godot. Let's see. Do we have a static code analysis Godot script? I don't think I've seen a static code analysis. Quality problems. Leveraging hinting, built-in checks, externals. Claude, the AI reckons it can do code analysis for you. So that's a relatively recent question. So it's saying static code analysis. That can tell you about the quality of the code, independent of the compiler and having it running. So, right. So warn about the unused types. You can see the warnings. So they're just saying that it's looking at the debugging code analysis tools built into Godot. Okay, back to the thing. So yeah, it is definitely showing other people. So code review is the way you know where it's good. That can code review be internally or it can be between groups. What I usually set up is sometime in October, seeing we've got through to mid-December, we start looking at October and November is when you start playing each other's games. Right? And even if you think, oh no, it's far too early, there's no value. The paired review, where you get someone else to look at their code, or you get someone else to look at your code and you look at their code, that allows you to do some of this, help the other person by giving them a review and seeing what's good and bad and also what you understand, which is beneficial to you because then you also learn more programming techniques because you get to see another project at a similar level by similar programmers. Right? So some of that sharing will be quite useful. We won't do that this week because Nipun is away, but what I'll do is for the week of for the 11th of October, we'll do some code/game sharing in the in-person session. Right, so that gives you some warning that we want you to have enough of a game to show other people in the class, and even if you don't have any game to show them, I want you to be showing code that you're working on towards getting the game working. And just share and get other people's opinions and see if they think there's a better way of doing it or if they understand what you're trying to achieve and how you achieved it. Okay, and that's how you learn about what's good. Okay. Should we take a 10-minute break and then come back and we'll break you into your individual groups and I will come through and do individual interviews to see how things are going and see where your games are up to. Okay, I've had no complaints, so we'll go for the 10-minute break and I'll turn off the stream and we'll start recording.